All right, let's start with day 4. Um, Congruences and proportions in similar triangles. So we're going to do some theorems that follow from the similar triangles theorem that we did in day 3, which is proving triangles similar. Okay, so let's start the warm up. We have a rectangle here, and we're trying to prove that triangle ABG and triangle DCF are similar. And as we said, the most popular way and the easiest way of proving two triangles similar is something we call AA similarity, which means we're going to need two angles congruent in this triangle, in the two triangles, and then the triangles will be similar. So let's see what we have. We have EFB and CGE, which are not inside the triangles, but which are supplementary to angles that are inside the triangles. And so we'll have our congruent supplements here, as well as the right angles from the rectangle, and then that will give us AA. So let's actually write out the proof. And I think today, being that with all that's happened and the fact that we're trying to shorten these proofs now, instead of longing them, let's actually just introduce a new shortcut for a congruent supplement. So if you're watching this, all right, all we're going to have to do, we're going to eliminate that whole supplementary business. We'll just go right into the congruent angles and their congruent supplement to make things a little bit easier on you. Okay, so we have a rectangle ABCD and angle EFB is congruent to angle CGE. Okay, both of those are given. Now we're trying to get to my AA, so the shortcut that I was telling you about is once we have the outside angle, let's actually just go for the inside angle. So angle EFC is congruent to angle DFC. So I want to make sure I got that right. And we can just say our normal supplements of congruent angles are congruent. And just mark it 2, because I think we've done such a good job with the setting up of the supplements that I think you guys understand it. So like I said, the better we understand something, then the less we have to explain. So on we go. All right, so that's my first day. Okay, and then we can say angle B is congruent to angle C if rectangle it's equiangular, or you can say if rectangle then they're right angles and right angles are congruent. That'll work too. And then triangle ABG is similar to triangle DCF by AA similarity on 3 and 4. Okay, simple. All right, so CPCTC is used to prove triangles, corresponding parts of congruent triangles congruent. Okay, well, CPCTC has a cousin. We're going to talk about what her name is in a second. But let's go over something we learned about similar triangles. So once we know that triangles are similar, we can use the definition of similar polygons to prove that, number 1, corresponding sides of the similar triangles are in proportion. Okay, in other words, if we set up a ratio between corresponding sides, those ratios will be equal. That's what proportional means. And the corresponding angles of the triangle are congruent. Okay, so CPCTC's cousin is going to come from number 1. All right, and CPCTC's cousin is something we call CSSTP, which stands for corresponding sides of similar triangles are proportional. Okay, and what it's going to allow us to do is if we know two triangles are similar, that's going to imply that the sides are going to be in proportion. So basically, if we know one, we have a similarity statement, then a proportion statement is going to follow after that. Okay, there's also going to be something that follows after that, but we'll get to that in a little bit. So the next thing is going to be going that step, and the reason for that step is something we call CSSTP. Okay, so then in the next slide, I'm going to introduce what I call levels. Okay, and similar triangle proofs will come in 3 levels. I'm going to call them, for lack of a better term, level 1, level 2, and level 3. Okay, level 1 is going to be, the proof is going to ask you to prove your triangle similar. No problem. 9 times out of 10, the reason for that is a similarity. And we told you there's 2 other ways of doing that, but they tend to not end up in proofs. AA is usually the most popular reason for that. The level 2 proof is when it asks you to prove that a proportion exists. Okay, so it might say something like AB over CD equals DE over EF or something like that. Okay, and the reason for that is CSSTP. Okay? Then they might ask you to prove a cross product. So you'll see something like this, where all these squares here that I'm showing you here all represent sides. Okay, so maybe it says AB times EF equals CD times DC, whatever. Okay, and the reason for that is our good old means extremes theorem, which is basically the product of the means equals the product of the extremes. And so it allows us to basically take this proportion and just cross multiply it. Okay, and that's all it is basically. So it's not some geometric thing, it's more like an algebraic thing. Okay, now the good news is that these reasons are the same all the time. Okay, and how far you have to go depends on what level they're asking you to prove. So, if they give you say, prove this triangle is similar to this triangle, it's a level 1, and you go as far as to AA, and it's your responsibility to find where the angles are. If it says, prove this proportion is true, then you have to prove not only level 1, but also level 2. So you'll prove AA first, and then CSSTP will follow after that. If your proof statement has a proportion in it, a cross product in it, then you have to go all the way to level 3, which means you need to show AA, then show CSSTP, and then carry it all the way to means extremes theorem. So if you have to prove level 2 or level 3, you must prove all the levels that come before it. Okay? And those 3 levels will always follow each other with in the same order all the time, with the same reasons all the time. So this right here on the top is something that should be memorized. All right, so we're going to do a simple example first, and then once you get the structure, we can then take it into more difficult cases of getting to level 1. But level 2 and level 3 will all be the same. Okay, so on the next page here, we have a nice example of a level 1 proof. Actually, it's probably a little before level 1, because they're asking you to prove that the angles are congruent. So this is actually not even one of our things. But suffice it to say that if this was a level 1 proof, this would actually be down here, and they would ask you to prove the triangles congruent. But this is actually just asking us to say that if the triangles are similar, right, that A is congruent to D, because corresponding angles in similar triangles are congruent. And I've almost never seen it where you need to take the angles away from the similar triangles. It's always always the other way. So let's just look at that for now. Let's just skip over that for now. Okay, example 2 is more of what I'm talking about. Okay, the proof statement is a proportion. So this is a level 2, which means that I need to prove the triangle's similar and then carry it all the way to CSSTP. Although in this case, of course, they already gave that information to us. So I put my level 1, which in this case is given and will almost never be. And then I carry it on to level 2. Now, here's a pro tip. If this ever appears in a proof statement, there's a technique that I use. I call the highlighting technique to kind of find the triangles that I need to prove in order to prove this proportion. It's a little obvious in this example, but this is the highlighting technique I'll show you for later. So you see these 4 segments in the proportion? I'll highlight them in the diagram. AB, DE, AC, DF. And I will highlight 2 of the 3 sides of the triangle, and that will be the triangles that I would need to prove similar. We will see that in future cases. But suffice it to say right now, level 1 is proven, so I go right into level 2. And what's the reason for level 2? CSSTP. Okay, and the 1 comes from the fact that you had to prove the triangles similar. So the ST part. Okay, number 3 is an example of a level 3 proof. As I can see, the proof statement is a cross product. So this is a level 3 type proof, which means that in order to prove that, I need to have level 2 and level 1 shown before that. Well, what were those levels? Well, level 1 was the similar triangles, right? Level 2 is the proportion. Oh, that looks like division. That's not an accident, but there you go. And then level 3 was the cross product that came from. So what we're actually going to do is build backward. Okay? We know that we need to end with the cross product. AB times DF equals AC times DE. And what was the reason for level 3? Do you remember? Means extremes. That's right. We'll put the numbers in a little bit, although I kind of know it's going to be 2. Now, what you need to do is work backwards from that. What was level 2? That's right, the proportion. So I need to figure out what proportion that this came from. So that means that this times this has to be equal to this times this. Okay, so in the green circle, that needs to be my AB times DF. So perhaps AB is here and DF is here. That makes sense. Okay, and then for the other side, I need to put AC times DE, and they need to be across from each other. So AC times DE. And so I have my proportion. Let's see if I can erase this. Not a chance. So we'll just rewrite it, I guess. So it was AB over AC equals DE over DF. And that will give us the proportion, the cross product in 3. And what was the reason for a proportion? CSSTP. So those reasons are always going to be the same. They're always going to follow their statement, their particular statement, and they're always going to go in order. Now, what came before level 2? Well, level 1, which is prove the triangle similar. I didn't have to do that. It was given, but usually my reason there is going to be AA. And we will see an example of that very shortly, because from now on, they're not going to give you the triangle similar just for free. You got to earn that. Okay, so now you know how to go forward to prove the similar triangles using AA, and you know how to go backwards, proving from at least level 3. Okay, and so now it's time to put it all together, and let's do an actual proof. Okay, so following page. Why don't you take a minute, pause the video, and let's look for a couple of things. Number 1, what level is this? Okay, and what has to come before it? Okay, and number 2, how am I going to get to level 1? How am I going to get to the AA from that? Okay, so pause the video right now and see if you can build your way all the way through to the proof. Okay, so I'm actually going to guide you through this whole proof process. If you were able to do it on your own, great, but you can also hear my reasoning for doing this. Okay, so this time we're given BD is parallel to CE. We'll get to that in a second. Okay, now I asked you a couple of guide questions. Number 1, what level proof is this? 1, 2, or 3? That's right, level 3, because it's a cross product, which means that I need to prove level 1 and level 2 before it. Okay, now level 1 is going to be my AA, so going forward from this, I need to know how the parallel lines are going to get me 2 angles. Alright, but first I need to know which triangles I'm after, so I'm kind of working this proof both ways. Since this is a level 3, I know that I'm going to end with AB times CE equals AC times BD. I'm not going to number it just yet because I don't know how many numbers I'm going to need. So what comes before it? You got it, the proportion. So how can I place these segments in such a way that I will get this cross product? That's right, you put them crosswise. So AB times CE would make it look like that, and AC times BD might make it look like that. And we already know the reasons, right? What was the reason for level 3? Yeah, means extremes. And what was the reason for a level 2? CSSTP. Now, I need to prove 2 triangles similar because that's my level 1. And none of these would follow without that. And do AA. But what triangles are there? Now, there's 2 triangles, right? But sometimes if you look ahead to like number 5, there may be some question about what the triangles are. So don't worry about that just yet. Just let's use our highlighting technique. So we're going to take the segments involved, okay, and we're going to highlight them as we read them. So I'm going to read this actually. Okay, let's read the segments. AB times CE equals AC times BD. Okay, now I've highlighted 2 triangles, 2 out of the 3 sides of 2 different triangles. What triangles did I highlight those sides of? Right, ABD and big triangle ACE. And that's how you figure out what triangles came from or produced the proportion. Okay, so now those are the triangles that I need to prove similar. how am I going to do that? How am I going to get my AA? Well, let's see. The parallel lines are going to give me corresponding angles on both sides, if you will, right? I also have the reflexive angle if I choose to use that, but since I'm almost out of room, I think I'm just going to use the corresponding angles. I have the parallel line, so my next bet, number 2, is going to be angle ABD is congruent to angle ACE, and angle ADB is congruent to angle AEC. Okay, and both of those are if parallel lines, then corresponding angles are congruent. Okay, or the reflexive if you wish. And now my proof's complete. That leaves with AA on number 3. That leaves me with the CSSTP for number 4, referring to the similar triangles on line 3, and the cross product for means extremes on 4. And that's how you complete a similarity proof. First, decide what level it's going to be, and then how are you going to get to level 1, right? And I showed you some tricks for connecting the 3 levels, like going from level 2 from level 1, the highlighting technique. Okay, so you can use that here. Okay, let's take a look at number 5. All right, so we have a parallelogram here and 2 sets of perpendicular lines, and we're here to prove that Sx times y equals Sv times Wt. So, let's ask ourselves the 2 questions. First of all, what level is this? Yep, it's a level 3, which means I need to do level 2 and level 1 before it. So, let's get on to doing that. Well, my level 3 is going to be the cross product, Sx times yw equals Sv times Wt. So what's level 2? Level 2 would be the cross product that came from. And let's place the letters crosswise, so Sx and yw this way, Sv and Wt this way. Okay, pretty much writes itself. Now the level 1. What triangles do I need to prove similar to do that? So we're going to use the highlighting technique, but this one's going to have a little twist. See if you can spot it. Let's highlight the 4 segments involved, reading line level 2. So Sx, Sv, and then Wt, and YW. It does not appear to be segments that are in a triangle, in fact. Well, there's only 2 triangles in the diagram, so that helps. Only XS and SV are actually triangles, so the pink ones are good, but the yellow ones not so much. YW and WT are not actually in the triangles. So this is actually a case where we're going to need to use substitution. Maybe those segments are not sides of a triangle in and of themselves, but maybe they are congruent to sides in the triangle. For instance, let's take YW. YW is not in a triangle, but can you think of a side that would be equal to the measure of YW that is in the triangle? That's right, ST, because of the fact that the parallelogram. So let me get rid of YW and let me highlight ST instead. And now I've got the leg and the hypotenuse of that right triangle. Let's do the same for WT. If we can't use WT because it's not part of a right triangle, what side is? You got it, YS. And now those are part of the triangle. So, because WT equals YS, or I should say their measures are equal, and YW, the measure of YW equals the measure of ST, I'm going to substitute one for the other in a proof. So I'm going to have to say that these two are equal, right? And then write a second cross product with the ones that actually come from the similar triangles. So SX and SV were fine, right? But instead of WT, it should be YS, and instead of YW, it should be ST. Okay, and that will lead to this. Nope, I'm going backwards. So, truthfully, this will lead to the triangle. This will come from the triangles YXS and TVS, which will lead to the cross product that comes from that, which will then substitute out for the one that leads to level 3. Okay, it's a lot of steps, but let's actually do it. Okay, so we start off the same way. I need 2 columns, I think, just in case. Okay, so parallelogram YSTW and the perpendicular. We're so involved in that, we didn't even discuss how we're going to get to AA, but let's get our givens down. SX perpendicular to YW and SVWT. Okay, in fact, just because this video is getting a little long, why don't I pause this and see how far you can get on your own, and I will come back in time for the substitution, okay? Work on this until you get to the level 1. I'll see you back in a minute. Okay, so here is the proof up through the AA. So if you're looking for a reason for the AA, one of them is the right angles, of course, which are congruent. And then the second one was the opposite angles of the parallelogram, which are congruent. So we knew that. Okay, so now, let's get rid of that. Now it's time to figure out where we go from here. So we achieved level 1 with the AA. Now we're going to start with the cross product that follows directly from the AA. So let's see what that looks like. So that one was the SXSV YSST. SX. Oh goodness, I forget so easily. SV YSST. These are actually sides in the triangle itself. Okay, so that is CSSTP on line 6. Now, we know we can't stay there because the cross product that they actually asked me to prove has different letters in it. So either on this line or on the cross product line, you can substitute. So we can actually do this here. Let's get this over with. So now we know that we need to get rid of two of these, right? The two on the right. So now we need to replace ys with wt. Oh, I forgot something. We need to show that ys equals wt before we even do that. And yw for st. And both of them have the same reason, which in a parallelogram, opposite sides are congruent. I'm not going to split hairs on the fact that they're saying the measures are equal, because the exact same thing would be fine if you chose to do with the segment line and the congruent. That's okay. All right, so now let's rewrite our cross product. Sx over SV equals, instead of ys now, I'm going to say wt. And instead of yst, I'm going to put yw. And I think I'll be in business. Yep. Okay, so this is substitution. And when you use substitution, you have to put the one you're substituting into and the justification that they're equal. So substitution on 7, 8. And now we can cross product that, giving us sx times yw equals sv times wt, which I believe is what we're trying to prove, and we can call that means extremes. So that is how you handle a level 2 or 3 with substitution. So you do that when the segments that you need to prove in your proportion or in your cross product, if they don't match the segments in the triangles that you've actually proven similar, but they're congruent to them. Okay, so that wraps up day 4. So just complete the assignment, and I believe we have an assessment coming soon. So keep a lookout for that, and write me if you have any questions. All right, bye-bye.